Good day, folks. Is this working? All right, just trying to get all my views better here. I was fine-tuning the template for the live view here, trying to make the windows bigger so you could actually see easier what I'm working on here and what I'm trying to show. So hopefully this tweaking is better. Let's see if I'm actually live. Yes, I'm live. Okay. So we're on a roll, folks. It's like the second time today I'm live. I guess it's a boring Sunday, right? So just saying hello again. And we're doing a lot of high Z and coil loops talking about that and how that could be used for resistors instead of having to use a physical resistor. There are some benefits of doing that, which I was discussing, and people are very interested in that. So I thought I'd do some demonstration with a little bit of mechanics, which I've basically hardly ever actually covered since the beginning of my YouTubing over all this alternate energy systems. I've been more into solid state, but I realized there's a whole domain out there with mechanicals, but I just really haven't really touched it very much. But not to say that I haven't quietly been experimenting myself with it. So yeah, just going on random saying hello. It always takes a few moments for people to show up, especially when I'm just live here and I don't announce. Most professional people will announce and say, "Hey, I'm going to do a live at this hour, everybody," and they give them a week notice, right? But it doesn't matter, right? Because at the end of the day, the recordings are all there, so they're all archived. So you see, oh, there was a live, and you could watch it later at your own pace. So yes, I will be talking more about using transformer coils as a source of resistance. The Z in the loop can be adjusted depending on how many windings and the thickness and everything of the coil dynamics, right? So that's something that people say. I'm really surprised that a lot of people didn't really know about this stuff before I just started randomly talking about it. But since there's obviously a spark of curiosity, I will go on in that direction and show you, crudely anyway, some possibilities here. So again, good morning, good evening, good afternoon, whatever it is, wherever you are. That's the thing about worldwide live streaming. We could be quite shifted in time zones here. Here it's actually, I don't even know what time it is here. My tablet will tell me 8:20, 8:20 p.m. I want to say something silly like 7. But yeah, it's 8:20 already, and I don't know why my iPad keeps. I better change that setting. I don't like that it keeps turning itself off after like 30 seconds here. It must be a screen time or something. I don't know what it's called. General display and brightness. 2 minutes. Oh, this is it. Never. I rather turn it off when I want to turn it off. So yeah, what I was saying. Hello, everyone, and 5:20 p.m. here. Nice. So some of us are pretty more in sync than others, maybe, which is to be expected here. Believe it or not, I'm still learning how to use this iPad here. So I'm just trying to get it to my whatever. Close enough. So yeah, as I was saying, hello everyone again. And like I was saying, I haven't really been too into the mechanicals, but like I was saying, not because I don't experimented with it, just because I've always been focused in the solid state stuff. But talking about the high Z loops and everything kind of brought me into this direction. I said, I'm sure the people will like seeing this. Maybe it will inspire for some people who are more into this direction here. So a few fascinating things can happen here in such setups when you start mixing and matching mechanics with solid state setup, especially in relevance to what I was talking about. Um, so I guess I don't know if it's too early to start getting right into this. Here we have a few people in here, but Oh, you have been talking about high impedance coil. I think you have been. You've mentioned that for a while in our chats, like right in like the Bedini stuff. Yeah, I think Bedini. Yeah, I don't want to start a big debate here, but I think it's something he was conscious of and well aware of himself, but wasn't so forthcoming about it, right? Yeah, exactly. It's all potential, and it's a way of having a similar effect resistance-wise without having to have a physical resistor, right? So you have that really you get the best of both worlds, especially when you start pulsing it through a coil, and then you start including, like I was getting at earlier today, through a high Q coil, then you build up the resonance, then the magnetics get stronger based on the Q of the coil at resonance. Then you end up with a resonant mode transfer. So you don't need the core no more. It becomes a magnetic resonance between coil A and coil B, kind of like a radio station setup, like Don Smith was trying to say, but you kind of got to set up the conditions for that. Um, so yes, is there enough people here to start talking about what I want to say here? Because this is some pretty interesting stuff. Okay, so I hope the view here is fine. I've been trying, maybe if I turn this light on here, I've been trying to get a better view here so people can see. So here you go. Again, I've never did videos like this, so I'm sorry, but this is basically the first time here. So you got to rate. So by the way, before I get into this, DC motor, 12 volts. DC motor here, much bigger DC motor, but it's got 200, if it runs at its full potential, 200 volts out, and it can sustain, you know, about, what was it? Does it say on there? But quite a bit of watts, like something like 60 watts or something. So it's a quite a big motor here. Now, of course, if I were to just feed, you know, the 12 volts DC, it's the equivalent of, you know, it's a heavy load. So this thing is like 5 amps. It would take the five. It would have no problem taking the whole 5 amps to spin that. So the quick solution that someone would think about is put a resistor, but then you get the resistor that warms up and everything. So instead, because this requires a little bit more energy, we can't go through the high Z, but we can go through the low Z side, like this transformer here, which still gives us like half of the of what it would give us without it, without the heating and anything. So here I have it connected in series here on the what would be the primary side, just feeding the motor, and I've got my power supply set to 12 volts. So now what's interesting here is we have a secondary, a high voltage secondary on this transformer. So this would be applicable, right, if this would be AC, but it's not. It's DC. But something fascinating happens when you start playing with mechanical motors, even if they're DC. Mr. Moran, if the name rings a bell, tried to tell us something here. That as a side effect, the brushes create high frequency interference, which is very high frequency, which propagates back into the system as RF. Very noisy RF. There is a fundamental frequency I could show you in a moment on the scope of about 1K. It's a very noisy 1K, which means that there's a harmonic at 10K and then 100K and on it goes well into the VHF range just by this noise here. So what's very interesting with antennas and tuning circuits and that sort of thing, one could capitalize on that noise as an additional tap, kind of like what Don Smith was saying about the radio stations, where you can couple into that without really affecting the source if you do it right. So that's quite something fascinating that happens with this, and it seems to be completely decoupled from the main system driving it. So I have my scope here on the secondary side to show you that we do end up with a very high frequency component when we drive the motor at DC. I'm taking advantage of the low Z side to drop it about in half, so instead of taking 5 amps, I take about 1 amp to drive this, because I don't want, that's the whole point, to try and be efficient, right? As long as this one here spins, on this side here, I'm getting 100 volts or more, which I will show you in a moment. DC, by the way. So we got the output of this. We got the motor here running through the Z here of the coil. We got a byproduct, which is an RF. And the primary field is actually quite very nice waveform, sine wave, by the way. So you get it's, I don't know how to explain it, but I'll show you. You get a sine wave, a nice sine wave that's about 100 hertz, and then a byproduct of those sharp high frequencies which go up to 300 volts or so. But you do see that 100 hertz sine wave there riding it. So with a little bit of filtering, you see 100 hertz is getting very close to 60. It wouldn't take very much to use that to run some sort of 60 hertz load is what I'm getting at. Ironically, the motor and the transformer core is acting as a crude inverter here on the secondary side, because you do have a core which has a kind of memory effect that is being pumped by the RF, and this naturally wants to resonate at whatever it's prone to, so you're getting that 100 hertz sine wave being generated with the noise of the high frequency. So again, all stuff in that Don Smith was trying to say. So I guess without further ado, let's turn this on. And this is a light, by the way, AC 110. It's not connected to anything, but I'll connect it to show you that the output of this is real. So we turn this on, very efficient. We draw about 1 amp at 12 volts to run this, a lot less than it would take to run it direct. And what's nice is I'm not wasting it on a pulse width modulator, and by not needing the pulse width modulator, by using a transformer, we're able to tap into these extra dynamics with it, which the pulse width modulator here instead wouldn't allow to give us all these extra taps, right? So it overly simplifies the circuit, and it gives us this wonderful magnetic domain to play with. So let's turn this on. By the way, remember, this is all DC, but we end up with an AC component as a byproduct, which we can harness and actually do something real with it, okay? So here I am, 12 volts DC. This is part of the noise, but you see here on the scope, I don't know if you can see that, those are the high frequency noises, 330 volts, but there's a perfect sine wave there that the core is doing. I can zoom into it a little bit, and you'll see it there. Look at that sine wave, it's almost perfect. And if I zoom into it enough, 120 hertz. It's a very slow, because it's the core, you know, this is supposed to be for AC 60 hertz. So they designed this inherently for low frequency operation. So this thing, it's like Tesla's impulse technology. You're feeding it impulses. The core is giving you back an AC sine wave on the secondary, plus the RF noise, which we can confirm with a radio here. You can hear it humming. I'll turn it off. This is just noise. You hear it like a vacuum cleaner in the background on the radio. So we're not even doing anything with this output right now. I'm just showing you on the scope. And the output of the motor over here, we'll turn on the meter. It's already connected to the meter for convenience. Takes a moment to boot up because it's a whole computer, this thing. 188 volts. 188 volts. So we could light up the lamp here. See that? That's a 110 volt lamp that we're driving. And look what's going on over here. The more we drive it, the more we get RF spikes. So the more we load it, the more RF we get. You see it over here. And we're still limiting the input from our power supply through the Z side of the primary winding here, feeding the motor. We're getting an RF component. The core here is filtering out all of some of those spikes and giving us a low frequency sine wave in there that you could use and filter for real AC. It's very close to 60 hertz. So, yeah, I hope I made a point here. So, again, just ideas of what you can do here. We're not routing any of these energies back or doing anything. I'm just showing you individually all of the taps all of a sudden we have and how we're getting an AC sine wave out of it completely. It's completely analog. You see what I mean? No MOSFETs, no switching. Just it's very Tesla-ish. Very Tesla-ish. We're using the spikes of the brushes to create those impulses through the core, which then give you back an AC like sine wave on the secondary. Like I said, very, very Tesla, all of this. And you could really go far, you know, if you start understanding the mechanisms behind all of this. And ironically, you know, I've never really done a demonstration with the motor because Mr. Moray, I find, did a very good job, but he hasn't posted anything in a while. So maybe it's time to take it from there because he was definitely onto something with his hyperdrive and then disappeared. I think he died of COVID or something, rumor says, when he was working on the controller in China, then disappeared. His account got hijacked and everything. But yeah, he was doing all of this stuff here. Yep. So I'm really happy everyone is understanding what's going on here. And that's what I mean by you want to cross domain, you know, the RF with the magnetics and all of that. And the more you can cross those domains, the more you end up with gain, basically. And you want to prioritize energy motion through gradient difference through field interactions. You don't want to go through electron flow if you don't have to. Prioritize field dynamics. Build up your potentials with that, and then at the end, close your loop. That'll induce a new EMF in that loop that will be completely isolated from the rest of your system, no matter what you use to drive it with. So, yeah, just so many examples. Some people are into mechanics, some people are into chemistry, some people are into all electronic solid state like Bedini's and Don Smith's. Some people are hybrid and like mixing and matching a little bit of both. Some people like Howard Johnson into all the hardcore magnetics. That could all work, by the way. But again, no free lunch, right? I mean, magnetics, even rare earth magnets will wear out after a while. But you can still get an efficient usage out of it if you don't have to pay very much and the thing runs for 5 years. I mean, hey, you know. But yeah, I mean, there's always going to be that argument that energy doesn't come out of nothing, and I'm not saying it does. Just you can maximize what's already there, and nothing stops you from recycling what would otherwise be lost, right? So yeah, there it is. So again, I hope you liked this demonstration. It was basically a short and sweet one, but I was really eager to get this point out. So again, I hope you all like, and until next time, and have yourselves all a great day. And of course, if there's something critical you want to talk about, It's best to do it in the video comments because it's hard finding it in the live chat setting. So if there's something you really want to talk about, just do it as a video comment, then everyone, including myself, will be able to see it and reply properly to it. So with that said, again, thank you very much all for watching and have yourselves all a great day. Thank you.